I'm going to talk about pyramids. I'll assume that you know what polyhedra are. I'll also assume that you know what volume and area are. If any of that is unclear, I would invite you to watch the necessary videos. So now let me define what pyramids are. Pyramids are polyhedra with a base and triangular faces that meet at a point referred to as the vertex. Now, let me also define what an altitude is. The altitude of a pyramid is the distance of the vertex from the base. All right? So let me draw some examples of pyramids. I can have a pyramid with a square base. Would look something like this. All right, so you see how there's 4 triangular faces that meet at a point above the base. Now I could have a base that is a triangle. So there's another example of a pyramid. And I can even have more complicated bases as long as the bases are polygons. Everything's fine. All right, and so make a bunch of triangles that meet at a point. Okay, so as long as you have a base that's a polygon and the other faces are triangles that meet at a point, then it's a pyramid. Now, a vertex does not have to be centered above the base. And also the base does not have to be a regular polygon. However, if the base is a regular polygon and if the vertex is centered above the base, that's what's called a regular pyramid. So the first pyramid that I drew, the base is a square and the vertex is centered above the square, so that is a regular pyramid. The second example, the middle example, the triangle looks like a right triangle. It's not an equilateral triangle, so that one is not an example of a regular pyramid. And then the base for the third pyramid, the rightmost example, is also not regular. So that's not a regular pyramid. Now I'd like to talk about the volumes of pyramids. Okay? Here is a formula that works to calculate the volume of every pyramid. The volume of any pyramid is 1/3 of the product of the base area and the altitude. Now, I'm not going to prove that this formula works for all pyramids. However, I will show you that it works for regular pyramids with square bases. All right, let me go ahead and do that now. imagine that we divided up the volume of a cube with sides of length L into 6 identical regular pyramids. What would that look like? So if you're having trouble seeing how I can divide a cube into 6 identical pyramids, the bases of the pyramids are the faces of the cube, and all the vertex points of all the pyramids are located at the center of the cube. So I'll draw the upside down pyramid that has its base forming the top face of the cube. All right, see that? And then there's another pyramid whose base is the bottom of the cube. Okay, and so I hope you can see how 6 identical pyramids form the cube of length L. All right, so the volume of the cube is L cubed. Since we have 6 identical pyramids, the volume of each pyramid is 1/6 the volume of the cube, so L cubed over 6. Now, let's see if that agrees with the general formula. The general formula is 1/3 times the base area times the height. The base area is L squared, right, because we have a square with sides of length L. The altitude of all the pyramids is L over 2. Okay, and indeed that simplifies to L cubed over 6. So the formula at least works for regular pyramids with square bases and altitudes that are half as long as the sides of the square. Now, what about if the altitude was smaller or bigger than L over 2? Okay, well, in that case, the volume would change by the scaling factor. So, in other words, if the altitude, the new altitude was the old altitude multiplied by, say, K, so L over 2 is the old altitude, and now the new altitude is K times L over 2. Well, then the old volume is going to be replaced with K times the old volume, K times V. Okay? And so that agrees with the formula 1/3 times the base area times the altitude. Okay? Think about that. It might help if you divide the pyramid into lots of little boxes, little vertical parallelepipeds. Okay? And if you increase one dimension of the box, let's say that you double one of the dimensions of the box, doesn't that double the volume? Okay, so that's the point I'm trying to make here. If you cut the altitude in half, the volume gets cut in half. If you double the altitude, the volume doubles. Okay, so all that is to say that the volume formula works even for those different altitudes. Okay, so 1/3 times the base area times the altitude. Now, let's do some examples. So, what if I had the following pyramid? So let's assume that the square base has sides of length 10 centimeters, and let's say that the altitude is 12 centimeters. All right, so what would be the volume of that pyramid? Well, 1/3 times the area of the base, 10 squared, times the altitude. So what would that give? That would be 400 cubic centimeters. Okay, what about the surface area? Can we calculate that? Well, finding the area of the base is pretty straightforward. What about the triangles? So to find the area of the triangles, let's do this. Let's form a right triangle that has legs. That one leg is the altitude, another leg is half the length of the sides of the square, and the hypotenuse is down the middle of one of the triangle faces. Okay? So what would the hypotenuse of that triangle be, that right triangle? Well, let's see. We've got the short leg has a length 5 centimeters. The long leg is the altitude, so that has a length 12 centimeters. So I can use Pythagorean theorem to determine that the hypotenuse has a length of 13 centimeters. All right? Now, that 13 centimeters, I can use that to calculate the area of the triangular faces. So the area of one triangular face is 1/2 base times height, so 1/2 times 10 times, now I can use the 13, and I have 4 such triangles, so I'll multiply that by 4, and then I'll add it to the area of the square, 10 squared, and let's see what that gives. So let's do some simplification first. So 4 times 1/2 gives 2. 2 times 10 gives 20. 20 times 30 gives 260. So we've simplified the expression to 260 plus 100, which gives 360 square centimeters. Okay? Now I would like you to do an example. Give me a minute to make a picture. So I've drawn a regular pyramid with a square base with sides of length 4√2 feet and an altitude of 3 feet. Would you please calculate the volume and surface area of that pyramid? So pause the video and try to do that now if you like, please. All right, so I'll go ahead and work it out as well. So the volume, I'll do that first. 1/3 times the area of the base, that's 4√2 squared, times the altitude, which is 3. Now the 1/3 and the 3 cancel, so I just have to square the 4√2. That's 16 times 2, which gives 32 cubic feet. All right, now to calculate the area of the triangular faces, I'm going to need some more information. So let me define a right triangle that'll help me to get some more info about the triangular faces. So I'm defining a right triangle with a leg that corresponds to the altitude, and another leg corresponds to half of a side of a square, the length of half the length of the side of the square. So one of the legs of that purple right triangle has a length 2 root 2 feet, and the other leg, the one that corresponds to the altitude, has a length of 3 feet. And using the Pythagorean theorem, we could find the length of the hypotenuse. So 3 squared is 9, 2 root 2 squared is 8, 9 plus 8 is 17, so the hypotenuse has a length of square root of 17 feet. All right? So the area of a single triangle is 1/2 times the base times height, where base means one of the lengths of the sides of the triangle. So 1/2 times 4 root 2 times the square root of 17. And I've got 4 such triangles, so I'll multiply that by 4. And to that I will add the area of the base. So when we're talking about pyramids, the base means the bottom face that doesn't have to be a triangle. When we're talking about triangles, the base means if the triangle is resting on a table, it's the side that's touching the table, that's resting on the table. All right, so that is the expression that I need to simplify. So let's see, the 1/2 and the 4s simplify to 8, because 4 times 4 is 16, divided by 2 is 8. And so the first term is 8 times the square root of 34. And the second term is 16 times 2. So the best I can do is get it down to 32 plus 8 root 34 square